Hey, well, welcome everybody today. So we have a pretty small group. I'll try to keep this, fairly informal. And we should have plenty of time at the end for questions, for discussion. And as we go along, if you do have any questions at any time, please paste them into the chat, and either I or my colleague, Nicole Walter, will do our best to answer those. So let me go ahead and share my screen. And can I just get a quick confirmation that you are seeing my slides?
Yes, we are.
Excellent. Okay, so let's go. All right, so today I'm going to be talking about data transfer. I think a really, really important topic. The content today is going to be relatively easy. But if you don't know, if you're not aware of these tools, I think you'll find that it really makes your life a lot easier using our HPC systems. So, just a reminder, I think most of you have been at complex webinars before. So this is a training program offered by SCSC, funded by the National Science Foundation, a 3-year award. And we cover non-programming concepts and skills that you need to effectively use supercomputers. So over the course of the series, we talk about parallel computing concepts, Linux tools, bash scripting, security, batch and interactive computing, how to get help, data management, and other topics. And this particular talk is the second talk in a 3-part series. So my colleague and one of the co-PIs in the project, Marty Candice, took over the topic of data management, and he realized there was so much to data management that he really needed 3 talks to do this. So I believe earlier in the year, we already discussed data storage and file systems. This is the second talk in the series. It's covering data transfer. And then finally, we'll have a little more advanced topic later on parallel I/O, how to make effective use of the parallel file systems, for example, like Lustre and GPFS. All right, so data management is a huge topic. It's a field of study in its own right. Here in the complex program, we're only going to be addressing a limited set of what we consider the most essential data management topics. We're going to be, not so much get into the philosophy of data management, but a little more of the nuts and bolts. That these are the tools that you use for compressing files, for creating archives, for moving data between systems. Now, at the end of this talk, though, we're going to be covering some projects like Open Science Network and Globus that go a little bit deeper into the issues of data management. I think for most of you, you may not need these tools or these services, but if you're setting up something that involves more complex workflows, especially if you're working with large amounts of data, let's say you're doing something that's tied to an instrument, a scanner, a telescope, a particle collider, a mass spectrometer. I think that you might find those all very, very helpful. So today's goals in data transfer, we're going to be looking at how you download data from the internet, how you check the integrity of your data, how to use data compression tools. Also, under that topic, we're going to look at using tar to create archives. We're going to look at some of the key data transfer tools, and then we're going to wrap up with a discussion of data distribution networks and federations. And we're assuming that going into this talk that you already know a little bit of intermediate Linux and shell scripting, and some familiarity with data storage and file systems. So if you haven't been exposed to these topics, don't worry. I think you'll still be able to follow along pretty well. All right, so what is data transfer? So when we talk about data transfer, excuse me, in the context of scientific and HPC or high performance computing, we typically use it as a synonym for file transfer. And this is just the process of moving a file from one computer system to another over a network communication channel. And this is mediated by something called file transfer protocol. So a data transfer may also refer to an individual instance of a file transfer. So there are going to be a few key components of any data transfer. First of all, what is the source? Where is the data located? The format. How is the data organized? Are we transferring individual files? Are we going to be moving archives that contain many files and directories? Are we going to be recursively copying directories and so on? Size is very, very important. How much data is there? So the tools I'm going to be talking about in the earlier part of the talk are going to be great when we're working with, maybe up to gigabytes of data, maybe even tens of gigabytes. But if we start moving very, very large amounts of data, we're going to want to use one of the services, for example, like Globus, that I'll be talking about toward the end of the talk. Of course, we need to know the destination. Where is the data going? And then finally, the method, and that is how should we transfer the data? So we're going to start with downloading data from the internet, and we're going to be talking about three tools, wget, curl, and aria2c. So wget is a non-interactive network downloader. So this is a simple command line tool for downloading files from the web. It supports HTTPS and FTP protocols, as well as file retrieval through proxy servers. And it's been designed for robustness over slow or unstable network connections. So if a download fails due to a network problem, you can set up the download to keep retrying, resuming the download from where you left off until the whole file has been retrieved. So we have a few examples that we like to use. I'm going to say, maybe try this on your own after the webinar. I'm going to discourage you all though from doing this as we go along, especially if you're all working on Expanse, because the amounts of data that are being downloaded, they're not very large, but still it could cause a little congestion if everybody's trying to download, say 100 megabytes or a gigabyte of data at the same time. So wget, I just find to be incredibly useful. So let's say you have a data set that you find on the web. You have a URL for it, and we like to use for our examples this CIFAR. It's a collection of images used for training AIs, and I believe there are multiple places you could find this on the web. For our examples, we're downloading this from the www.cs.toronto.edu site, and there you're going to see a number of different files. There's the CIFAR 10, there's the CIFAR 100, and I'm trying to remember what the difference is between the two of those. There's also Python, MATLAB, and binary versions. So, this will give you data that's, say, I forget what it is in Python. I believe it's pickle, is their compressed format. MATLAB has its own compressed format, and then there's a standard binary format. So if I just want to download a single file, this is pretty easy. wget followed by the URL pointing to that file name. So in this case, we're going to be downloading a compressed, that's what the .gz extension means, archive. We can see that it's a .tar file of this image data that we could then use for training. If we want to download multiple files, we can use wget with the -i option, followed by the name of a file that lists all of the URLs. So for example, if we wanted to download the Sci-Far 100 Python, Sci-Far 100 MATLAB, and Sci-Far 100 binary, and not have to write this out, do multiple wgets, we could just put all of those names into a text file and use a wget-i. And then finally, we can resume a download. And this is really, really handy. Sometimes you'll be downloading a large file. Something will happen. There will be an interruption along the way. Let's say your connection was broken. For some reason the download stopped. You can use a wget-c to continue where you left off. So, this works surprisingly well. I was experimenting with this yesterday, where I started downloading this this large file from imagenet.org, this ILSVRC, etc. So I started downloading it, and then I deliberately stopped the download. I did a Control-C. And so now the file was partially downloaded, and then I just did a wget-c, with the URL pointing to that file, and it picked up right where we left off. So very, very handy. You don't need to start from scratch if your file transfer was interrupted. And here we're looking at binary data. We're looking at say archives and compressed files. But this is going to work for any file. So I don't know if anybody's ever gone to a website. Let's say there was some text data that you took. You might have manually copied and pasted that from the web page into a local file. You could use wget for those files also. All right, there's another common tool for downloading a file from the web, and that's curl. Curl is a very sophisticated command line tool, and it's also a software library. And it's, again, like wget, for transferring data from or to a server using various network protocols. By default, it's going to invoke HTTPS GET request on a URL, and it's going to display the retrieved data to standard output. Now, curl, like I said here, it's a very sophisticated command line tool. If you log into a system, look at the man page for curl, it is very, very long. In fact, right there on the man page, it even says, I forget what the exact wording was, but that it's a long man page, and it's kind of daunting to read. For most of you, wget is going to be perfectly fine, but if you have maybe some more sophisticated things that you're trying to do, and given that curl is a software library, you should be able to write C or C++ code and interface the curl through its API. So the kind of the simplest way to use curl is curl, and here I'm going to use the -O flag followed by the URL. And what -O tells us is that we want to save the data in a file that has the same name as the URL, but without the full path. So for example, if I do a curl-o https:// etc. Through sci-far-10-python.tar.gz, if I use the -o option, I'm going to end up with a file sci-far-10-python.tar.gz. Now, like wget, we can also download multiple files. So for wget, the flag was -i. For curl, it's a $K. And what this says is that I'm going to download the files that are listed in the text file. Now note that the format of that text file, though, is a little bit different. Instead of just listing the URLs, I'm going to provide my flags, in this case $O, like we did in the previous example, and then followed in the next line by URL equals, and then in double quotes the the name of the file I'm trying to download from the internet. And again, just like wget, this could be an arbitrary number of files. So just be aware that if you are using curl, that the syntax of that input file is going to be a little bit different. Like wget, curl allows you to resume a download. Here I use the $C flag, and I believe, yeah, for wget it was a $c. And then finally, I can download multiple files in parallel using the $Z flag. Now, just be aware though that there are multiple versions of curl out there, and the last time I tried this on Expanse, the -Z option and the corresponding long option --parallel didn't work. I need to talk to our folks in user support to see if they deliberately installed a version of curl that would disable the parallel downloads. So just be aware that that -Z option for parallel downloads may not necessarily work everywhere. And then finally, and this is, I'm going to say, a less frequently used tool, ARIA2C is another command line tool for downloading files. Supports HTTPS and SFTP, as well as BitTorrent. And more interestingly, it can download a file from multiple sources over different protocols in parallel and tries to utilize your maximum download bandwidth. So again, a fairly sophisticated tool. If we just want to download a file, a single file, it's ARIA2C followed by the URL for that file. Like wget and curl, we can also download multiple files. In this case, it's the -i option again, and where the text file just lists the URLs. We can resume a download with the $C option, and we can download a file in parallel with multiple connections per host. So in this case, we are using the flag -x2 to say that we're going to try to download this file with 2 connections simultaneously. Okay, are there any questions on downloading files with wget, curl, or ARIA2C? Right. If not, I will move on to data integrity and checksums. So I'm doing for time. Okay, good. All right. So data integrity is related to the present. I'm sorry. I see a couple of comments in the chat. Let me just check these. Okay. Yeah. Question here from Hadia Bayat. Quick question, what is meant by more sophisticated? You mentioned to use curl for more sophisticated, I guess, downloads. I would say that it's, oh, yeah, Nicole, and I'll get to that. Thank you for posting that comment there. Yeah, so Hadia, I would say it just gives you more fine-grained control over the type of downloads. And to be honest, I really haven't done, I haven't done much with, much with curl, because I typically just see a file that I need or a collection of files, and I just use wget. The other level of sophistication there is that it is a full software library. So as I mentioned, you should be able to integrate calls to curl directly within your C and C++ codes. And Nicole, great, thank you for addressing the parallel downloads. For everybody who's not reading the chat, Nicole wrote that they had disabled parallel downloads to avoid overloading the login nodes. And excellent point that we have special data mover nodes designed for dedicated data transfers. And from Jiang, hi Robert, you might have covered this, but in which cases would you use wget, curl, or other tools? I overwhelmingly just use wget. And I had talked to Marty Candice, who was the developer of this presentation, and asked him his opinion, and he said the same thing. It's virtually always wget. But again, um, if you're trying to do something where you need maybe more fine-grained control, especially if the file transfers are, say, part of a regular workload, you might want to look into the options for curl. But again, I'm not really an expert in curl, so I think I'm going to stop there. Oh, and for ARIA 2C, what one of the strengths there is that it does allow those parallel downloads where you can go out and look for multiple, um, where you can investigate downloads from multiple places where the file may exist. All right, so let's move on to data integrity. Yeah, and thank you everybody. Those were some great questions. Now, data integrity is related to the preservation of data consistency over time. So you could think of integrity as being the opposite of corruption. So in a nutshell, we want to make sure that when we download a file, that that the copy that we have here is exactly the same as the copy at the source. So we want to make sure that there were no errors, no corruption during the download process. So we're going to be talking about a few tools that you could use for checking the integrity of a file that you've downloaded from the internet and ensuring that it has not been corrupted. And again, we're going to be looking at these examples of the SciFar data set. Okay, so I'm going to be covering two tools that are, not used as much anymore, and they're actually a little discouraged, but you may see them, especially in scripts and workflows that that you receive from your colleagues. So a checksum is a small block of data. You could think of it as like a fingerprint or an ID derived from another larger block of data, which can then be used to detect any errors introduced into the larger block, either during data transfer or long-term storage of the data. So this is a little confusing because checksum is both a concept and it's the name of a tool. And we're going to discourage you from using the Linux checksum tool. So a checksum is typically implemented using a hash function, which you could think of as taking an input data set of an arbitrary size and generating a fixed output value known as the hash value, the digest, or simply hashes. So again, you could think of it as a fingerprint associated with that text. So we show here examples of generating checksums from different inputs. Of course, these are trivially short, but you can apply a checksum to a file of any size, even multi-terabyte or petabyte size files. So we're looking at various input texts here. We start off with fox, and then the red fox jumps over the blue dog, and then the next example, the red fox jumps OUER, the blue dog. So this was we deliberately introduced an error in the text. And the important thing to note is that each time the input changes, the checksum changes. And the tools that we're going to be talking about, they're all designed so that even if there's a single bit that's changing in the data set, that we're going to get a different checksum. So you'll notice in these, for examples of the red fox jumps over the blue dog with various errors, the third line shows the V replaced with a U. The line after that shows the E and the V in over swapped. So we have OEVR. And in the last example, we had the deletion of a letter. So instead of OVER, we just have OER. And again, in each case, the checksum is different. Checksum should be very easy to compute, and it should minimize duplicate output values for different inputs. So if we have two different input files that give us the same checksum, we consider that to be a hash collision. Now, but given the length of the checksums, the number of bits, these hash collisions are exceedingly rare. Like if you were creating texts and running these checksum algorithms continuously, it would probably take you like the age of the universe to get a hash collision, especially with the recommended tools. But the main thing is, again, that they detect very small changes in the data, down to a single bit. So, tool that you're going to see a lot, MD5sum, is a command line tool that calculates and verifies a 128-bit MD5 hash value of the file. Now, you're going to still see MD5 hashes in use, but note that the underlying algorithm is no longer deemed to be secure. And by secure, what we're worried about is somebody deliberately modifying a file and trying to hide that fact from you. So for example, if I have a file, especially with very critical data, like financial data, we don't want somebody to be able to go in there and change a value and still get the same MD5 sum. Unfortunately, there are security issues with MD5 hashes. But if you're using this, just for moving files between machines, you're probably going to be okay, but I wouldn't use this for anything secure. Very easy to use, MD5 sum, name of the file. It will generate the hash. We can generate the MD5 hashes of multiple files. We can output that to a file. So in this case, we're looking at the Scifar, Python, MATLAB, and binary files. We're outputting the results to a file called scifar10.md5. And then we can use MD5sum with the -c flag to check and verify the MD5 hash values. For example, if we look at the contents of that .md5 file, we'll see a list of the files, their sizes, the MD5 sums, and we can use, again, MD5sum-c on that file to make sure that none of the data has been corrupted. Now, what we're going to recommend, though, is even though you see MD5sum, the tool of choice now is SHA-256sum. So this is a command line tool that calculates and verifies a 256-bit hash. So recall that MD5 was only 128 bits. So this doubles the size of the hash, greatly reduces the likelihood of hash collisions, but more importantly, it's what we call a cryptographic hash function. And it's designed to detect internal tampering. And this is recommended checksum utility that you should use rather than MD5sum. And the usage is essentially the same as MD5sum. We can apply it to a single file. In that first example, we could apply it to multiple files and write the results of the hashing to another text file. And then we can use the -c flag to confirm that the files have not been corrupted on disk. Okay, so before we move on, are there any questions on data integrity and checksums? And I'm not seeing anything, so I will move on then to data compression. So data compression is the process of encoding information using fewer bits than are used in the original representation. And this reduces the resources that you need to store and transmit data. And there are two types of compression techniques. We call them lossless or lossy. And for what you're doing, if you're working with scientific and technical and engineering and image and other types of data sets, what you're overwhelmingly going to want is lossless compression. And this means that you can reduce the size of the file and that you can exactly um, exactly reproduce the uncompressed file. So again, the original data is reconstructed from the compressed data with no information loss. And a lot of the algorithms that we're going to be using for lossless compression are based on this Lempel-Ziff algorithm. Now there's also something called lossy compression, which reduces the number of bits to store that file by removing unnecessary or less important information. And this allows lossy methods to achieve much higher compression ratios. Now, you might be wondering, when would I want to use lossy compression? A common use case would be, when you're streaming video over the internet. So if there's minor if there's minor errors in the data, we really don't care. Or if we're just viewing the data, right, rather than going back and analyzing, sorry, not viewing the data, say viewing a video, we may not care that there is that we've lost some of the information. But again, for the kind of work that you're going to be doing, we all want to use lossless compression. So there are two tools that we're going to be using, gzip and bzip2. So gzip is a command line tool for file compression and decompression. It uses a combination of the Lempel-Ziv and the Huffman coding. And whenever possible, each file is going to be replaced with one with the extension .gz. And it's going to keep the same ownership modes, access, and modification times. So we're going to start off with decompressing a file. This is probably something that most of you have done already. You might have downloaded a file from the internet or received a file from a colleague. We're just going to use gzip-d. So the -d flag says decompress, and then followed by the name of the compressed file. So in this case, scifar10python.tar.gz. You can also decompress using gunzip, G-U-N-Z-I-P for g-unzip. They do exactly the same thing. If you want to compress a file, just use gzip followed by the file name. If you want to decompress multiple files, you can, and keep the originals. Again, I could use the -d flag. I could use -k for keep. And this is going to work for both compression and decompression. And I could compress files with different speeds or levels. Now, I've experimented with this in the past. If you use the gzip-1, that's going to be the fastest compression, but it might not give you the greatest degree of compression. So your files might be a little bit larger. And -1, I believe, is the equivalent to --fast. So this means do the compression very quickly, but again, may not necessarily be the smallest file. You could also use the gzip-9. This would be the highest level of compression. This is going to take longer, and this is equivalent to --best. Now, to be honest, the experiments that I've done in the past with gzip found that these compression speeds or levels really didn't make much difference. And I saw there was, sorry, let me go back here. I'm going to try to get to the chat. Ooh, okay, so from Martin, yeah, great question. How does the algorithm determine whether the data is statistically redundant or unimportant in lossy compression? So I believe what happens is there's either a discrete cosine transform or fast Fourier transform is applied to the data, and then it will deliberately deliberately leave out the data that corresponds to higher frequencies, or to the highest resolutions. So it's going to be selectively removing data that may not be apparent to the viewer. So again, it is throwing away data, but it's throwing away data that is in higher frequencies where it may not be noticeable. And Martin, hope that answered your question. Yeah, it's a really really important topic, and this lossy compression is really the reason that you can you know watch YouTube videos over your phone, in what seems like real time. Okay, so we talked about gzip. Now there's a parallel version of gzip. It's called pigz. And you can see that's gzip backwards. And this can be used for doing compression in parallel. And what was I going to say? Oh yes, but it can't do the decompression in parallel, which is generally okay since decompression is very very fast compared to compression. Now, when I would really recommend using pigz is as part of a batch job. Let's say that you've generated a large file, and you still have that compute node, however many cores could be 2 cores, 4 cores, maybe even the entire node. And while you have that node, you might want to take advantage of having all of those cores and just do the compression rather than, say, going to a login node and doing a serial compression. So again, it's going to have the same options as gzip, but there's one additional option that you would be interested in, and that's down here at the bottom. You'll see that we have in that bottom line, we do a compression with -p2. This means 2 threads. And the second example, we do a compression with 4 threads. And I believe by default, if you don't specify a number of threads, you will get number of threads equal to the number of cores. And I see the question had popped up here. Let's see if I could get back to the chat.
That's just a comment on compression.
Oh, okay. All right. Great. Thanks, Derek. All right. So moving on, we also have a tool called bzip2. And this is another file format and command line tool for file compression. You're going to use this exactly the same way that you use gzip. Most of the arguments are the same. You could use bzip2 to decompress a file, -d for decompress, or bunzip2 equivalent. We could compress a single file. We can compress a file and keep the original, compress or decompress. To keep the original, we're going to use the -k flag. And we can also check the integrity of the compressed file to make sure that nothing happened, that it wasn't damaged during the compression process. Now you might be wondering, if we have gzip and bzip2, when should we use which one? So I find that gzip is generally faster than bzip2, but the latter, bzip2, almost always results in smaller files. Now, the degree of compression that you're going to get, that's going to depend a lot on the nature of the data. We find that text data is much more compressible than images. So if you've ever read about what is that? Mental block here. Claude Shannon's work on information entropy. A random string of bits actually contains the most information. It has the higher entropy. So things like images tend to be very, very high entropy and aren't very compressible. So here's an example where I took the sci-far tar file and I tried compressing it with gzip and bzip2, and that's the first block of examples here. And we can see that gzip only resulted in about a 10% reduction in the file size. So if we look at the ratio of the original to the compressed file, it was only 1.09. bzip2 did a little bit better. We had a compression factor of 1.25. In neither case did we really gain much by doing the compression. Now, I also looked at some a couple of text files. So one of them is a FASTA file. So this is just a list of all of the protein sequences in an organism. And here with gzip, we got a compression of 1.82. With bzip2, we did a little bit better to 2.08. And then finally, I just downloaded the text of Moby Dick. And here the gzip gave us a compression factor of almost 2.5, bzip2 a little over 3.25. And I'm also going to post a link later to a experiment I had done for a immunology project a few years back. And for those files, which I guess have a lot more repeated data, we were actually able to get a compression of about 10x using bzip2. So again, gzip is generally going to be faster. If speed is a consideration, use gzip. But if you really don't care about the speed and you're more interested in ending up with the smallest files, use bzip2. Okay, we're going to move on. We're going to talk about tar. I think a lot of you have seen tar files already. So tar is the tool for bundling a collection of many files into a single file. So some common flags are we use -t if we just want to list the contents of a file. -f indicates the file name that we're going to be working on. We can extract all of the files from an archive. We can create a new archive using the -c flag. So here we're going to use tar-cf, the name of the file that we're compressing, the name of the archive that we want to get, and then the file or directory that we're going to be archiving. And we can work directly with files that were, we could create the archive and we can do the compression at the same time. So we could use gzip with the -z option. So in this second last example, tar-czf, this means they're going to be creating a new archive. Z means they're going to compress with gzip, and F indicates the following file name. And we can also use J instead of Z if we want to create an archive that's compressed with bzip2. So it's just convenience. You don't need to use these options, but if you do this, you won't need to do this in a two-step process. Now, one thing about tar files, there's something called a tar bomb, which is where you expand a file and it just fills your directory with files. So the right way to create one of these archives is put all of your files into a directory and then apply tar to that directory. And then when extracting files, the directory structure will be reproduced. Now, the wrong way to create an archive is put all the files on the command line. And upon extraction, the files will all be written to the current directory, potentially leaving you with a big mess to clean up. Most people know to create archives from a single directory, but I've already encountered these tar bombs. It's not usually done maliciously. It's just because somebody was a little careless with how they used tar. And you can see an example here on the right that I created a tar file just from a list of files. In this case, it wasn't so bad. It was just 3 files, file 1, 2, and 3. But sometimes these these archives can contain thousands or tens of thousands or even hundreds of thousands of files. So again, make sure that you create these the right way. And if in doubt, when you're extracting files from an archive, you might want to create a temporary directory where you do that extraction. So just in case you do have a tar bomb, you don't end up filling up your entire home directory with all of those files. And I see a couple more comments in the chat. So Derek wrote, some tools will also let you deliberately discard some data. You can discard transparency info from images and so on. Yep, excellent point. There are tools. These are usually for, say for photo processing that are very, very handy. And then Tong Yao said, are these compressions all lossless compression? Yes, when we use gzip and bzip2, they are lossless. Um, and is it important to check the integrity after compression? It's one of those things that I don't normally do, but I would recommend it. I think it would be I think it would be a good practice. And then, yeah, the second question there, what information could it possibly remove from text files? Again, if it's lossless, there would be nothing. And I don't even know how you would apply a lossy compression algorithm to text files. Again, lossy compression is usually done on image or video data. All right, so let's move on. Okay, I am running short on time. I'm going to go through these pretty quickly. Secure copy, sorry. We're looking at tools now for actually transferring data. So earlier we looked at downloading from the internet. Now we're going to be looking at moving data between machines. I'm going to say the most common one is secure copy. Command line tool to securely transfer a copy of files between a local computer system and a remote system, or between two remote systems. And this is based on the SSH, or Secure Shell Protocol. And SCP is included by default on almost every Linux and Linux-like operating system. So if you wanted to upload a file from your local system to remote host and rename the file, so in this first example, we're doing an SCP. The scifar10 python tar.gz is the local file. And in this case, it's being transferred to my colleague Marty Candace's account. He's using the Oasis DM interactive file. These are what we call the data mover nodes, especially specialized hardware used for data transfer. And this is the best way to do the transfers if you're working on a system that does have these data transfer nodes. And then at the end, colon, and then tilde / scifar10 tar.gz. So this is the location of the file. The second example, he's just doing this in the opposite direction. He's moving something from the remote host to local. You can also do this with an entire directory. Many of the Linux commands have a -r flag, which means recursive. So these next two examples are essentially the same thing, except we're transferring a directory rather than an individual file. And then finally, at the end, we introduce the -C flag, which means that we are going to do the transfer with compression enabled. Now, SFTP is an interactive command line tool, also based on the SSH file transfer protocol. One thing that's nice about SCP is that we can easily script it. It uses a command line interface, whereas SFTP is going to be an interactive tool. And I'm really not going to go through the details here. Main thing is these get and put commands, and then commands like ls and cd, standard Linux utilities for, say, listing files and changing directory, are all going to work from the SFTP prompt. Now, rsync, I'm just going to mention this very briefly, but it's a really, really powerful tool. This is a command line utility for transferring and synchronizing files and directories between two storage systems over a network. And most importantly, it determines which files differ between the two by checking the modification time and the size of the files on both ends. I find rsync to be incredibly useful if you're working on a project, say a distributed project, that involves the regular generation of data. So years ago, I had worked on a multi-university collaboration, involved a bunch of wet labs. They were each night on their local server, they were adding new data files. It was genome sequencing and Western blots and and videos and so on. And we would want to transfer all of the data to SCSC so that we could aggregate and process it here. By using rsync, we didn't have to go back and look at each file and say which files are new, which are modified. It would automatically do this transfer in such a way that it would only transfer the files that are either new or that had been modified. You'll see that the syntax is pretty much the same as SCP, but there's one flag that I want to point out here, and that is the -A flag. This means to use rsync in what we call archive mode. And what that means is it's going to preserve the permissions, symbolic links, ownership, and so on. So again, if you're regularly synchronizing data between two systems and you want an easy way to just move the data that's been modified or the new files, rsync is the way to go. All right, I'm going to wrap up. I'm just going to talk about a couple of tools and projects that are out there. Now, I mentioned earlier that SCP and rsync, these are great if you're moving relatively small amounts of data. But Globus, this is a nonprofit organization run by University of Chicago. They've developed a lot of tools and toolkits for file transfer, and they have a grid FTP based service with a really nice but both command line interface and a web interface. And this is the way to reliably transfer very large amounts of data. And it's also ideal if you have regular workflows, say where you're regularly processing and transferring data, say generated by an instrument. And let me just get back to the chat again. I saw something pop up here. You know what? I'm going to get to that. Oh, there we go. Chat. Is there a version of rsync that runs over SSH? I don't know, Derek. I'll have to get back to you on that. And if I don't know the answer, I will check with my colleague Marty. And then is Globus compatible with S3 and other cloud storage providers? You know, I don't know for sure, but Matt, I would say I would be surprised if it was not compatible with S3. But I would have to go to the Globus site to confirm that. And Nicole, great, thank you. Thanks for answering Derek's question. All right, rclone. This is a powerful command line tool for managing files on cloud storage, like Amazon's S3 object storage service. Lots of capabilities here, supports more than 70 different storage backends with a number of advanced capabilities, also has POSIX file system support. Again, not going to go into detail here, but if you're moving data back and forth, say between one of the access allocated HPC systems and say a large object store, say so like Amazon's S3, that this is the tool that you would want to use. And then finally, I'm just going to mention these very quickly without going into any detail. There are a number of data management projects out there. There's the Open Science Data Federation, and this is designed to support sharing of files in an autonomous data origins, provides efficient access to those files from anywhere in the world via a global namespace and a network of data storage caches. And this is integrated with the Open Science Grid, a high throughput computing project. This is very heavily used by the astronomy and the high energy physics communities for sharing and accessing some very enormous data sets. We also have the Open Storage Network. This is another distributed network of storage systems, aims to make data storage and transfer at scale simpler for scientific research. And then finally, the National Science Data Fabric. And again, that this is more of a test bed for data delivery and access to shared storage. So if you have, more sophisticated data transfer needs that involve sharing of very large data sets or moving instrument data between labs, these are all excellent solutions. So I'm going to wrap up there. I'm going to get out of presentation mode and let me take a look at the chat. Right, so, okay, Nicole, great, thank you for confirming that Globus is compatible with S3. Like I said, I didn't know for sure, but I would have been shocked if it didn't. Surprised. And then from Brian, is there a good guide for Globus out there somewhere that you recommend? I would just say go to the, let me go back here to the Globus website. Yes, so that is a active link in the slides. And we could also paste that into the chat. Yeah, so if you go to the Globus website, they have very, very good documentation on all of their tools. And then finally from Matt, and this is a long question. Apologies for the very niche question. If I have a directory with over 10,000 individual TIFF images, summing to about 3 terabytes, and I need to transfer these to S3. I've been using AWS CLI to upload the data as is, but wondering if it is generally advised to compress this before uploading. This is the process I have to repeat for a few hundred separate image stacks. I'm sure is dependent on outgoing data transfer speeds and CPU available, but I'm wondering, as a rule of thumb, if the time it takes to compress images is worth the speed up in data transfer. Okay, so first of all, I would recommend, starting beginning here, if you have these 10,000 individual images, that you may be better off creating an archive. So use tar, put these all into a tar file, and upload that single file. Now, when it comes to compression, so some of these tools do data compression on the fly. So we'll integrate the data transfer with the compression. But my recommendation generally is that I would just compress the file. I would create depending on, how long it takes to do the compression, that you might be better off just compressing the file and then having that file moved. And that would be especially valuable if many folks are going to be doing a download of that file, so that if the file transfer does involve compression, that it doesn't have to be done each time. So again, I would recommend creating that archive and generally compressing that before you move it. And I am all done. So we're now into the question and answer session. Let me close that. I'm going to stop sharing. And yeah, so we're just a few minutes past the hour. Everyone feel free to unmute, turn on your cameras if you have any questions, or if you're more comfortable, you could just paste them into the chat and Nicole and I will do our best to answer them.